So yeah, I had a talk just previous, like 1 hour, no, 1.5 hours ago, about the Azure and or not Azure actually, only Terraform infrastructure as code. So this is like a workshop or the demo part of it. So you can ask questions in Armenian or Russian if you want, but just like for everyone to understand, I think like I'll just make it in English. Did you have a question? Yes.
Before getting started,
yep.
I'm wondering what is the difference between, let's say, Terraform and like other GitOps tools, and are they considered to solve the same problems?
GitOps tools, like I mean, GitOps tools are
Flux CD or something. I
mean, no. I mean, Flux CD or other GitOps tools you will use mostly for deploying the applications within the infrastructure resources. Like if you have Kubernetes or Lambda functions and so on, you will write some sort of deployment code for application deployment on the infrastructure, on the Kubernetes and so on. But the Terraform handles, takes care of creation and management of your infrastructure code. So you need to have a Kubernetes to deploy your app to. So there is no Kubernetes. So Terraform does for you the Kubernetes deployment configuration, and you can actually use it for deploying the applications as well if you want. Maybe not the best.
So, like shortly put, the GitOps tools will work only the Kubernetes cluster.
Or like with similar, yes, but like GitOps tools are usually for the software development purposes. You can actually run Terraform on GitOps tools as well if you want. That's the how you run, and I'm actually going to show you like the Azure DevOps and how to run the Terraform on the pipelines for the infrastructure part. So you can use the GitOps tools, but the GitOps tools are just like execution of something to run against something else. And Terraform is more about like a tool to create resources within the cloud. So they serve the different purposes, let's say. So that's main difference. Maybe it will be clearer when we go like through the slides. Yeah, so topic is about how to manage Azure infrastructure and scale. And here maybe the main point, scale, meaning that you are maybe not just going with a basic like one environment configuration, but you actually need to manage multiple environments. So I'll show you some tools that you can use there. So maybe shortly about me. So I'm cloud architect consultant, started with the software development in the beginning, and for past 8 years mostly been working like now with cloud and big data, and within Azure like working for like past 5 years around. And like with the topics like microservices, Kubernetes, Databricks, and Terraform. So in the software aspect, infrastructure aspect, all parts of it, the security. So in the overview of the session, there will be the problem definition first, what we are trying to solve, then some tooling, and from the tools that we will be using is Terraform and Azure DevOps. Then we will try to put all those tools together for solving our problem, and I'll show you some demos actually, like how you can use those tools and where to find some like links and so on. So let's start from the problem definition. So we start from like, this is something what I've been already talking about, but just fast recap. So if we start from a cloud migration is a process where you have some data assets or some workloads, the machines and everything that you have in on-prem. If you have like, usually like cloud is pretty new, considerably new, let's say maybe past 15 years around. But there were quite a lot of systems existing like on-prem, like with the data centers of like companies that they build themselves for serving like their own services and so on. So now companies go and migrate those data assets or digital assets into the cloud to utilize the elasticity of the cloud, to utilize the power, the limitless, let's say, so-called, of the power. So then we are talking about cloud migration. Not all the companies will. If you are working on a startup, you will have a greenfield like deployment where you will just have stuff already in the cloud, or you will start straight away within the cloud. So then you don't do cloud migration, then you will just start from the empty ground, but same tools still apply. But in this cloud migration case, if you are starting to move your data assets, or not data assets only, but like digital assets, let's say workloads and so on, to the cloud, if you start from the data assets, so you have some databases that like have some data and you want to utilize, create some reporting, analyze them, machine learning and so on, you could start migrating already those data assets into the cloud and create a cloud data platform and like solving analytics and all kinds of like, for all kinds of purposes, use the data. Usually the architecture of your cloud data platform will be like based on multiple subscriptions. And you will implement some sort of like, even if you don't have on-prem connectivity, still there is a good idea to implement the hub and spoke network topology. Because if you have, like, if you imagine the top part is dev environment, bottom part is prod environment, or just like different production type of environments, and they need to be connected somehow to each other, that you can do fast queries between them, that they don't travel through internet, then you need to peer them somehow and provide the connectivity. And hub and spoke topology is the most used one, and that will provide you connectivity between all the virtual networks and workloads that live within different subscriptions and even across the tenants and so on. So now we are talking about multiple subscriptions, multiple type of the resources and so on, and they can be tens, hundreds, or thousands of different resources that you need to manage. And in my previous talk, I was talking about that those like infrastructure as code tools that you could use. So I'm not going to go through all of them in a way, but like I'll just talk about what's the specifically with Terraform. So, and what's the problem in this specific use cases when you are building the data platform cloud? This is supposed to be animation, but it's not. So imagine the babies are your customers, so there are quite many of them, and then a couple of adults only is your team. So you have a small team, but you have like tens, maybe hundreds of customers that you need to centrally manage all their but their own specific data platforms with some tools, and like keep them up to date, update, provide the infrastructure, orchestration, everything. So there should be like some sort of very good tooling existing. So only Terraform is not going to help, because like Terraform itself just to work with one cloud, then if you are having like not one cloud, like one environment, but if you have like hundreds of them, then you need some tooling around Terraform as well, and some like more kind of performant tools around it. So let's talk about Terraform and how it can help us. So this like description about the Terraform. So it's a open source infrastructure as code tool that provides you consistent CLI workflow, meaning of the consistent CLI workflow that it hasn't been changing for like past 10 or whatever amount of years that Terraform exists. So you have main commands, Terraform init, Terraform plan, and Terraform apply. That works same way regardless which version of Terraform you are working with. So like you can always rely on those being there and just use them. So you write your infrastructure as code using the HCL configuration language, which is HashiCorp configuration language. It's a small DSL. Then you will run the Terraform plan that will show you what is going to happen actually. So it's a dry run. It's not going to execute and create any resources. It will just show you what is it planning to do. And looking into plan, if you check, is this what you expect? And if that's like exactly what you expect, then you can run apply. So this eliminates the problem that can come, that's like some side effects of the code that you might have, or something that has been changing in the cloud in your environment that has been done manually, for example. Someone could go through UI and tweak something and change something within the portal, and then you will actually see that there is some kind of changes that are not expected, and Terraform potential will try to override them, and you could see it before you apply. So some production issues might be like, you wouldn't have any production issues because of that, because you didn't like delete something that accidentally was done manually, for example. And then, yeah, you apply, and then the Terraform will take care of actually executing all the code, error handling, retries, and everything, and make sure that everything is up and running. So for working with the multi-cloud setups, you have those providers, and providers are just, so if you are working programmatically with the command line interface or the CDK, SDKs and so on, then you, it's all on you to just write the REST calls, making specific code executions and so on. So you are kind of the one who is implementing this provider in a way. But if you are using Terraform, these providers are kind of open source community supported. Usually the big players like AWS, Azure, and so on, they will be the ones implementing the providers for you. And they are taking care of exactly all this interaction of that you write a piece of code and what will happen in the Azure part, how Terraform will take care of it, retrying and everything, all the logic. So you don't need to care about it. And that's nice part of it, that you can just leave it for the people who know what they are doing, let's say, in a way. Like professionals, they did this and it's supposed to be working. So it kind of eliminates extra steps that you need to do. So and there are providers for these major cloud providers, AWS, Azure, Google Cloud, and many others. And then you got providers for Kubernetes, Helm, Databricks, some open source tools and frameworks, and some SaaS, popular SaaS services like Auth0. And there are like around 3,200 providers right now, and the community is growing. There are like official ones, there are community ones, open source, like different levels. So of course, when you start and you use Azure, usually it will be like the official provider by Microsoft itself created, or like same with AWS. But there are many open source, just done hobby projects, let's say, and so on. So all that is around 3,200. So the state is quite important to be able to run that plan and apply, separating these steps, and that you will be able to see what is going to happen when you are going to be applying specific configuration. Terraform needs to figure out it from somewhere, and that somewhere is the state. So whenever you are applying something with Terraform, Terraform will save all the things that it was able to create, let's say, within the state. And next time when you will run Terraform plan without any changes, it will just figure out, okay, like configuration didn't change, state didn't change, I'm not going to do anything. But if you will add something, modify something, and so on, so when you run the plan, Terraform will check your state file, compare it also with the cloud, how it's looking like, and then it will provide you the plan on what is it actually going to do, what updates will happen, and so on. So it's kind of crucial. Some competitors, just shortly, briefly to mention, Pulumi. That's another open source infrastructure as code framework, but the main difference may be that is you should use a programming language like TypeScript, JavaScript for writing a code. And this one, I would recommend this if you have a team who is working with your infrastructure who know programming and familiar with those. So if you have a developer background, people who are working with infrastructure, this is a very good choice because you can use all the toolings, testability, and everything, create modules, distribute same way as your software. But if you will be having people who work with infrastructure that are more like classical software administrator who work with Windows and like no mostly scripting, Terraform and Terraform HCL will be like just the DSL version. The pure Terraform will be much easier for them to learn and understand. So that's maybe the main recommendation from my side will be when to use Pulumi and when Terraform. Terraform provides the CDK, which is the programmatic approach or like coding approach to the infrastructure as code as well that supports JavaScript, Python, and so on. But it's still experimental. So they didn't release yet stable version 1. APIs are changing all the time, and even they don't recommend using it. But the good part about this that if you in the future want to actually use CDK when it's available, that's a good part of Terraform as well, that you can start with DSL, and then because it's the same engine that is running, working with the state and so on, you should be able, hopefully in the future, seamlessly just migrate your code into the using CDK instead. So that's kind of nice part about the Terraform, but currently not really working well, let's say. And then there is Azure specific like DSL Bicep, which is DSL over ARM. So ARM is Azure Resource Manager templates. The older way, JSON-based templates that you write your infrastructure, it's like very maybe unreadable and so on. So like the better option if you want to go just cloud native, if you don't have choices like if you don't have use cases for managing Helm, using Helm, managing Kubernetes and deploying something that is not Azure, for example, specific or AWS specific, then the Bicep or then CDK from the AWS are the better maybe options to use because they provide the feature support out of the box more or less. So whenever the Azure comes out with something new for some resources, you can expect that Bicep will support them. So that's the better choice between. But the Terraform is kind of multi-purpose kind of tool in this case that you can use. So let's have a short demo here where I'll just show you something that I've been just showing in the slides in my presentation. So here is our Azure subscription or like Azure portal from where you can see that I have like specific subscription and there are no actually any like resources under it. Like there is some resource group, but like there is nothing there. This is just like they're supposed to be. So now we want to deploy something. So let's take a look into some code and see how we can deploy. So here I have a small demo. And in this small demo, like this taken again from the presentation that I had earlier, we have the block about Terraform required providers. Here we say that we want to use the Azure provider. you provide a source, and it's a good idea to log to specific version, because if you don't log the version, provider version might change, there might be some breaking changes, and your code potentially might not work. So to have a reliable and always kind of working code, it's a good idea to always provide very specific version, or provide the range in between which you know that it's working, so whatever is available it can download and use. So, and here we'll go all the so you can put your Helm provider, Kubernetes provider, even AWS if you want to deploy into multiple places, but from one project. So here we'll go you will need to define which providers you are using. Then after that comes a block about configuring that provider. You can keep it empty without any features, without any configuration, but if you want to configure the provider to use specific type of authentication, like service principal or specific managed identity and so service principal, that configuration will go under this provider block. So you are able to customize it for your own needs. So after those two blocks, which are more high configuration for Terraform to know what's your code about and how to connect to specific environments, then you start actually writing the code, the beef, as they say. So here we have a resource group. So resource group, if you are not familiar with the Azure, resource group is something, it's like a folder that if you have Windows or Linux operating system, you can't have files just lying around. You should have files under directories folders. So resource group is just flat structure of folders within Azure that provides you a grouping of similar resources under the same namespace, let's say resource group under the same folder. So in this example, we will be creating in this first part resource group. Then in specific location, West Europe, cloud has multiple data centers. Here we say we are using West Europe, and here is the name of our resource group. Then we will create network security group for within the same resource group. As you can see, we are reusing reference to this resource created earlier and referencing the name of resource group, because those are the expected arguments that you need to pass for being able to create network security group, the location and the name of it. And then we create the virtual network, and under network we will have two subnets, and one of the subnets, as you can see, will reuse the network security group that we created under that we have in the earlier step. So let's try to run it, and yeah, it will add some tags as well. So let's try to run this code and see what happens. So here we are in the small demo, and we start with Terraform init. So this is the first command that you run. What Terraform init does, it just scans your code, checks what are the configuration options that you have, what providers did you specify, how the connections should be made for your state and that kind of things. And as you can see, for example, it initializes the backend. That's where the state will be saved. Then it will be checking out what the providers this configuration relies on, and will try to download it for you. And in my case, I have it already downloaded, so it just uses the local cache. So after this, we can run Terraform plan. That will actually, again, scan the code, and based on what we have in the configuration, we'll try to see what it has to do to make, or what's going to be created, let's say. Because we don't have a state, we haven't been applying this before, the state is empty, everything's supposed to be new resource, so it will try to actually create everything. Let's see if it actually works, because it has been failing, the network is slow. So here we can see the output of the plan. So it will be creating for us network security group example, as we have here. And as you can see, the parameters, they are much more or actually, sorry, on this one, resource group, there are much more, for example, there is ID. There are many things that are having a default, for example, that you don't need to specify, but you can change and make your configuration bigger, and if you don't want to go with defaults. But by default, it has some defaults, and it will try to use them if you don't provide anything of your own. So here we have a resource group creation, here we have network security group creation and the virtual network. So it says that you have 3 new resources to be created, nothing to change, nothing to destroy. So in this case now we will try to run Terraform apply. Apply will show you the same. So it will first show you plan and then ask you for if you want to apply it or not. But there is non-interactive way where you can provide a flag where it will just run over and create it. And also you can actually run, you can create a Terraform plan output and dump it to the file, to one separate file. So let's first check it. So you can see the same changes, everything. And now it asks, do you want to apply this? And you need to say yes in this case, because we are using interactive mode. And then it will now start to create these resources. So yeah, what I was saying, Yes, so it's very good idea to run the plan, take plan output and dump it to a file. There is like a support within the Terraform plan that provides the parameters for it, and then take that output file as a parameter for your apply, because while you run the plan, if you are waiting, for example, if you have a plan output in your pipeline and then you are going to apply, like let's say in 15 minutes, there might be something that already happened to your cloud and your plan will not work anymore. So next time, if you will be running the plan, it might have completely different output or expectations there. So your cloud might change, let's say. So it's a good idea that whatever output you have and whatever output you have seen, to save that and provide that as a parameter for your plan run, that it will be executed. Then you are sure that there will be no any side effects in it. So now we apply it, and let's check what we got here. It might take some time, but here we see example resource group. That's the name that we provided for our resource group, and under this example resource group now we have virtual network security group. And if we check the network security group, or actually we can maybe check from the virtual network itself, subnets, you will see that there are these two subnets that we have been creating. And if you check subnet 2, or I can just move this a bit this direction, you can see that there is a security group in use. So our network security group has been used for the subnet 2. So this is just what will happen. And let's see now, I will have a small code snippet. Let's try to modify our code and see what will happen next. So let's go to network security group. This doesn't have rules. So network security group is for the virtual network or for subnet is a software firewall. You define within the subnet, if you have any resources, how the can resources connect to something external from the subnet, and can anything from the external outside of subnet connect to the resources within. So it's like software firewall that is provided by Microsoft. So here let's put the security rule that will say that, for example, we have inbound security rule that will allow TCP connection on all the protocols and for all the destinations. So here we got a code, and I will run Terraform apply straight away just to not waste some time. We will still see the outputs before applying it. So what this will check now, it will connect to the state. It will check the configuration, compare those two, and see is there any drift, any difference between them. And then it should figure out that only the security rule was added into the Terraform configuration, so it's doing a plan. And here you see changes, like don't pay attention on the tags. This is something automatically applied by policies, so it's not in Terraform code, but this is a change that you see. So the only thing that kind of changed, and it was able to figure it out, is that there are one security rule added. This is the changes there. So there are no any new things to be created, nothing to be destroyed. Only like three changes because they are like tags changed for some resources, but like one that we are interested, this is this one. And these are exactly the side effects, as you can see. So something might be happening within the cloud that's not part of your code, that is enforced over the subscription, some policies, for example, and Terraform will show that this is something that is outside, and I will try to delete, for example, those. So now we can say yes, and then after some time, we will see that there is, let's go to our network security group. Let's see that there are no any inbound security rules. So yeah, here is the overview. These are the default ones, and now after they apply, we should see that there is one security rule added. It should be pretty fast to apply. And meanwhile, we can actually check into, so it has been applied. Let's refresh. Here is our rule, priority 100, that's the name, and that's the rule allowing like TCP connections to everything, more or less. So I will show you Terraform state itself. So here is in what format. So it's kind of like a full representation of your cloud infrastructure that Terraform tries to capture within the state file. And this is supposed to be the truth for your environment, let's say. If there is anything that is not in the state file, that means that it has been somehow applied to your environment outside of Terraform that Terraform is not aware of. And that's not something what you don't want to have, because in that case it's really hard to figure out why the change is there, is it needed or not, and so on. That's why you should have, you should use always Terraform or like whatever tool, infrastructure as code tool you are using for capturing everything what you do within the cloud, like in one place. Now I'll just, for the next demo, I'll prepare and like just run destroy command. Destroy, that will like actually delete everything that we have been creating so far. So let's run with it, yes. Some tips for organizing Terraform configuration. So I had pretty simplistic like code, but like there are like pretty good tips that you can actually start using from the beginning. So if you start small and you have like small environment building, that's fine if you have just one Terraform code, the one Terraform project and one state file. But while you are adding more and more and more resources and you are reaching like hundreds or thousands, it's not going to be performant if you run, save everything within one Terraform state. So if you know that you are going to have like a big environment in the future, it's a good idea to start to plan it beforehand in a way. And the planning here is that first of all, like separating each environment, you have dev, pro, test, and if each of them are going to be in a separate subscription, for example, it's always a good idea to split them into, for example, separate Git repositories, that their life cycles are not like intertwining. And there are specific use cases where you would like actually to have pro, test, and everything, one code base, but just different variables or configuration for it. That's another approach that you can do, but in all cases you need to separate dev, prod, and those parameters or the say variables that you give to your Terraform code into separate places and manage them separately. Then you could start thinking about the actually some sort of infrastructure architecture there and introduce some sort of layers within the infrastructure and separate projects that are responsible for building blocks of infrastructure. For example, you will always usually have some generic subscription level configurations or networking or some firewalls and so on. So you could kind of like put that into one project. We will see some examples later on. And then separate the components or like resources that have a similar life cycle within the same Terraform configuration and the same Terraform, like save them in the same Terraform state. That will minimize the blast radius for the changes, that if you are doing changes for the networking, it's only kind of like related. I mean, networking is a big one, it can affect everything, but still like if you have a separate small project that deploys some and configure some specific small application, then it's not going to be affecting anything else that will be managed by other Terraform projects within other states. So if something breaks here, it's not going to affect anything else in your bigger environment. And then the plan will run faster because there is less things in your state file, and the plan needs less time to figure out what's the changes that it needs to do. So that's the way to accelerate. So that if you put all the 100 resources under one state file, it might take, as I said, half an hour. But if you separate them into smaller kind of pieces, smaller blocks, like microservices, let's call it, then the plan will be just dealing with like tens of resources. So plan will be much faster, and apply in that case as well. Like will go. I mean, apply is not so much affected, but the plan at least you will see the changes what you are doing like faster. Then we can define and use some modules. Terraform modules provide you this kind of way to configure doing the same stuff over and over. Like it's like a library, let's say. So you define a library that does one thing. For example, you will create always Kubernetes cluster and configure specific ways, and you need to deploy that Kubernetes cluster 10 times. So you can write a module, you can write how you want to deploy it, and just reuse a module everywhere. So this kind of promotes the code reusability and writing once and using multiple times concept that you have in the software development as well, let's say. So kind of the same concepts apply here as well. Let's actually, I'll provide here yes that it will get destroyed, and let's continue. And another one is the security and stability related like tips, let's say, locking Terraform version, module version, and provider versions. That's what we did in our code. So we have the saying that we are using specific version, that you will not have any side effects that are not expected, that always like a code will behave the same way as like regardless if there is a new version of something or not. So it's like, and then you have a more kind of robust way of upgrading the provider versions and checking if your code actually works with them. And if it does, then you roll out it for the development use, production use, or wherever you want. Then the storing state file in a shared encrypted storage. Like as you saw, the Terraform state that I have is like in my machine. So in this case, and by default, that's the configuration that will be there. It will be created on the place where it's executed and stored there. Now imagine if you have like other guy who wants to work with the same infrastructure. He doesn't have access to state file, and without the state file, you can't do, or not that you can't do anything, but let's say if I'll run now Terraform plan and apply in environment that is kind of without this state file reference, it will think that there is nothing because state is empty. And it will try to create all again, and then when you will run it, it will say, hey, actually there are resources that are already available. They are not in the state, so if you want to configure to work with the Terraform, you need to import them into state. So it's not like manageable. You need to, state is a shared resource. You need to have it in a place where all the people who are supposed to work with infrastructure will have access to. And that's why you can use the remote backends that are configured, configure the state reference that it will be in the S3 bucket in AWS or in the storage account in Azure or some place that everyone will have access, whoever are working. Yes?
Is it a bad practice to store it inside the repository? Because
yes.
the secrets also.
Yes, exactly. It's a bad because you will get a lot of secrets if you are generating secrets. If you create some cluster and it has certificates or something generated, created, all that will be in the state file. And you don't want that it will expose, and it's always bad practice to put any secrets in the Git repository. So it's possible, but don't do it. That's why you will use something like storage account or S3 that provides for you the authentication out of the box, encryption, and those are as like in my slides was like pretty like you need to version because backing up state file, versioning it, that if something goes wrong with the state, if you break it for some reason, then it's always nice that you can go back to the previous version, that you don't have any downtimes and like in a big trouble that you are not able to use your automation. You don't do that, yeah, maybe you don't want to do that as well, yes. But like there are out-of-the-box support for it for like blob storages, for example, and so on, that every single change will be stored as a separate version. You can keep only like 30 last versions or for 30 days and that kind of stuff. And of course, like access, because it has a lot of secrets, access to it should be like audited, least privileges, only people who should have access to it will have, who are working with the environment and so on. Those are applied. So now let's check the Azure DevOps. So now we have a tool to run the infrastructure, but as you see, like if I'm doing it from my machine and then I have like multiple environments and so on, it's not like the most performant way to do. Maybe I'll not have a network connectivity even, or I need to have a lot of accesses personally to all the environments and so on. So it's not really a scalable way. For being able to scale out, like we need now to use some other like tools, and here comes like Azure DevOps, and this is maybe GitOps related and like those practices. Like Azure DevOps is not the only one provides you support, but while we work with Azure, we are using like Terraform to deploy stuff in Azure. There is like Azure DevOps that has like nice integration with Azure itself. So like let's take a look. But you can do the same with like GitHub or GitLab or whatever you are using, but it might take more time to like set up all this stuff. So who is familiar with Azure DevOps? Okay, so one person, good. So Azure DevOps is like a full-blown software management SaaS service, let's say, that you could use for, so it has Azure pipelines, which are just generic CI/CD workflows that you can run, similar to like what GitHub has. Or any other like nowadays has. So you can run some pipelines that will be running somewhere in the cloud and running against your requirement, building your software packages, deploying them, or whatever you want. There we have Azure boards that is more like a Jira for the software process management, creating tickets and all the stuff. You have artifacts, that is the software packaging, NPM repositories, Maven, Nugget, and all the other like package feeds. Azure repos, that's just repositories, similar to GitHub, and Azure test plans. We will be using Azure pipelines and Azure repos only, so the rest don't really matter, but it's kind of full-blown service that you can use it for like a big teams managing their software development, like life cycle fully, like having code there, having processes there, tickets and everything like regarding to the software. So it got some extensions, over 1,000. You have extension for Docker that will add like out-of-the-box support for some Docker commands that you don't need to run command line interface tools themselves. You just say use this like extension and run the build. We will see some examples. So it has quite many extensions, and most popular ones, even Terraform is supported, but in our case we are not going to be using this one. And from the resources that are in Azure DevOps, so it starts with organization. I'll be showing this, that is like for the whole your organization, you will have like one DevOps space, let's say. Organization consists of multiple projects. Then we will be using agent pools, in our case self-hosted agent pools, that make, so you could run the pipelines on Azure's own machines running somewhere in the cloud. But in our case, we would like to do such a way that like environment that we are going to be working with will be bootstrapped from within the environment itself, let's say. And for that, you need self-hosted agents that are running within that environment. I'll show maybe it in the like later on. But like in our case, we will use self-hosted agents, so it's our VMs or Kubernetes cluster or something running like the same agent, Azure DevOps agents that will be just connecting to service. They will be available, and you can use them for like running any build task or deploy task or whatever. Then we'll be using repositories, YAML pipelines, and the environments. And let's take a look into. So here is an example of YAML pipeline. It's like, yeah, it's a YAML base, as you could guess. So the structure is that you have the pipeline, the whole pipeline. It will consist of multiple stages. Each stage might be consisting of multiple jobs, and within the jobs you will have multiple steps to run, like the function, commands that you want to execute, and passing like from one to another, and so.
It's like GitHub Actions, right?
Yeah. It's like GitHub Actions, like all the environment, GitOps kind of tools have the similar kind of pipelines. Let's say this has its own. And on the right side, you have like some example of a pipeline that will be, so the trigger will define when the pipeline will be automatically triggered. If you specify the branch master, then whenever you push to your master branch or merge to master branch, the pipeline will trigger automatically. Then resource, you don't really need to specify itself, meaning that it's like with the Git repository that you are using, the pipeline is within it. You can define some variables, and then the stages that you run, and you can have just steps actually in the most kind of simplest YAML pipeline. You can just have a steps. You don't need to have the whole big hierarchy. And in this case, for example, we have stages. In under stages, only one stage. Under stage, only one job, and that job is calling like Docker extension that will be running the build command against like the code, and will build the Docker image. Then you can combine it with Docker push or whatever other things you want to do. Maybe before this you want to run some testing to check that actually everything is fine and so on. So this way you will build the YAML pipelines. Now let's try to put it all together. I'll just give you some like high-level architecture overview on actually like what we are going to be building. It's like not, let's see if maybe I can try to make it bigger. Nah, it doesn't go bigger than this. So we will have one organization. And within that one organization, the DevOps organization, we will have multiple projects, project per customer. So we have customer 1 who has its own data platform, customer 2, and so on. So each of them will have their own projects, because you want to isolate. You have the access control between the projects, so each project will have its own list of people who can access it, who can modify the code, and so on. And of course, because those are two environments of two separate customers, you want to separate them completely. So that's why you will use separate project for those. Under the project, you will have multiple Git repositories, and we will use the model where we'll have one Git repository per one environment or subscription of customer. So if you are dealing with a big environment that has like 10 subscriptions, you will have 10 Git repositories. Each subscription Terraform code will have its own repository. Then we will be splitting, as I said, like because we will have like a big environment, or targeting to a big environment, we will go from the beginning with the microservices, let's say, where we will have a smaller Terraform project, but still all that is going to be in one monolith, let's say, repository, but every small project will have its own state file. So we can run it faster, output, see the differences, and only deal with specific smaller size of infrastructures. So each project, Terraform project, is going to have its own pipeline to run and apply, because it will have its own state file. And then we will have agent pools that will be deployed to that specific environment. So if you have like this like Git repository that is for production, then you will have like tens of Terraform projects underneath of it. Then you will have like the production subscription itself, and the resources of the Terraform automation are going to be deployed within that environment itself. So kind of you work from within the environment to deploy the environment, let's say, and scale out. And please ask questions like if this is not kind of like clear enough, then later it can get harder. So please ask question if something is like not clear. The structure of repository, so as I said, we are going to have like one Git repository but multiple projects. So one structure that works pretty nicely, like for example in the cases where I work with all the like use cases for multiple companies that I've been working, is that you create so-called realms. And the realm is a combination of multiple projects that have a similar life cycle, let's say. So you could think of like a core realm, which will be the base for your environment, where you will create something very important that you always go with whenever, whatever environment you have, always need to have. For example, some... No, not that level. It will go with, for example, in every single subscription, you might have some sort of networking if you go with that hub and spoke topology that I was showing. So that networking part is essential. It's a foundation for your subscription, for all the rest of the workloads that you will have. So that's the thing that you will put maybe within that core realm in some project that will be creating virtual network, will be creating subnets and so on, and make it available for the environment for the rest of the projects, let's say, to come. So that's the foundation minimally that you will install, and everything that has like kind of shared usage will go there mostly. Then, and it will consist, the realm itself is just abstraction, so it just consists of multiple projects. And similarly, like integration realm might have, if you have like integration with the on-premise or some external sources and you are building this big data platform. So you have one centralized data lake, you want to bring all the data from multiple sources into one storage. You will you will need some components that run these integrations. Like in Azure, Data Factory is a good tool, for example, for running integrations, connect to databases, dump data as a files into the data lake, and so on. So then you can think about like integration realm, and everything that is integration specific will go there. No one else needs to know about it. No one else needs to deal. So it's a resources set of stuff that it's like has its own life cycle. And there is no any external dependencies of other things to it. So you will put all that under that specific realm itself. Let's take a look into and here is like, for example of this. You have core realm, these are the projects. These are actually the Terraform small projects, microservices. Then integration realm that will have its own, and so on and so on and so on. Then the realm and environment. So we will be using so-called pipeline environments. And the idea here is that, so we have Terraform Plan and Terraform Apply. Infrastructure is usually a pretty crucial part, so you don't want just blindly run and apply whatever you create, like whatever you kind of wrote on your feature branch and so on straight away to environment. So it's always nice to separate them and introduce some manual step. So we are going to have a plan pipeline, and then separately a stage, and then apply pipeline. Which means that first we will run the plan phase, you will see output, and you will see what's going to happen, and then manually you will approve propagation of that into the production applying phase, kind of, that will say, okay, this looks fine, now I want to apply this, and you will kind of manually approve that. For that, we will be using the environment logic, and we will create environment per realm. You can do it differently. You can do it on project level if you want, and so on. So minimize as much, or have just one. But in this case, this gives a possibility for different teams to approve their own pipelines. If you have integration team, they can work with integration realm and approve their own pipelines without affecting anything else. So this is a way how you can split it. So now let's go to the demo, and this is going to be taking some time. And so what I'll do, I'll actually run one thing and then go through, in the beginning, and then go through what's happening in the background later. So here is our, so to start with, I have, there will be a resource page in the end, so you can actually check it yourself. Here is a GitHub, it's open, you can go download this. This is a starter project for the being able to run on those self-hosted, or this will create for you self-hosted agents within specific environment, and will deploy and connect the agents to your specified Azure DevOps organization. So you can use this, and we will be using this. I'll just demo it like right now. So here we have the Azure DevOps organization. Here we'll have a project. Let me create a project for this. I have some backup project in case. So this will be a Barcamp. So I create a project. I can say is it private, public, and so on and so on. So the project, it will be, so Barcamp is my client. I create a project for the Barcamp, and now I'll be kind of creating the rest of the resources. So I have the, let's close this one we don't need, this one we don't need, and let's save this is not important. So yeah, so this is the Terraform Infra Bootstrap project, which will be creating quite many like resources for us, but that's the part that will take care of like the left side, so this corner. So it will create for us agent pool that where the agents will be connected to and where I will be running my pipelines on. So this will take some time, that's why let me like run it straight away. Here I have the Terraform Infra Bootstrap, is the same project folder. Here I run a Terraform init to initialize my project. And then I'm going to have exactly same code base that I'm going to deploy for all my clients. So this code, it doesn't change. The only thing what's going to change is the target. So I need this for my automation to work. That's why I'm going to use the same code base, same resources that will be created over and over again for all my customers to work with. But what makes the difference is this like configuration file. So here I say like what's the naming convention, how many, which version of Terraform I want to use, what's the DevOps URL for that environment, how many agents I want, and that kind of things. And here will be the, for example, for a Barcamp. So this will be the one that will be in use. So actually, looks like I don't have time. So I'll actually go now to show the thing what I already have. And let's check this. This has been done for the backup project. So let's check how it looks like. So in the backup project, this is a project. Again, under the project, I have repositories. Here is the demo. So as you can see, following what I was talking about realms, here I have only one realm called core. And in this core realm, I have like two projects. Pipelines is just a templating way how we can use Azure DevOps pipelines. That's why like every single level will have its own. You can take a look into in the GitHub how it's done. There is explanation for it. But our main projects are the storages and VNets. And the first one that we need to have, and like what we are going to be creating, is a VNet project. It has its own Azure DevOps pipeline, as you can see. This is a template where it says be triggered on main, and it provides some path on where the trigger is, because I have multiple projects. I want to trigger pipeline only when change happens within specific path within itself. That's why I have like path included. And then I specify some project path which will define also what's the state file within the shared storage account where the states will be saved. So, and this will create for me resource group and virtual network and so on. So it will take a look into the pipeline part for it. Here we have pipelines, two of them, demo core storage, demo core VNets. This is a pipeline. If I click edit, you will see the same code and is referenced from the through the path itself. So here I have been running it. So, and these are the stages. So you can actually see how the stuff is working. Here I have two stages, plan and apply. In the plan, stuff is running and it shows what are the changes. It's same stuff what you saw on my console when I was running it. Here you will see what's going to be applied, what's going to be outputted. And then when you go to the apply change, the pipeline will stay there, stop. And as you can see, there is one check passed, approval. And it's using approval environment. So I manually went and approved the pipeline, said it's okay for me that this will be applied. And if there will be side effects, I could cancel it, and like nothing will be actually applied to the environment itself. And the approval goes with this environment here. So here is my core approval environment that I create. And under this one, there are approvals and checks saying that this specific person or team, you can use a team here as well, needs to approve before it goes to the next stage. So transitioning from the plan into the apply. So this is the pipelines part. And every single project, as I said, will have its own plan and apply. So this is actually the repository itself. Let's move it to this side. So you have a core realm. Under it there is storages and VNets. Now the trick here is that, and how you can work and create microservices in this case, or what that means is that the VNet creates something and it's output something. And now we need that something that has been created to work and create some other resources that are utilizing the shared stuff that has been created here. So we have the output that will be saved within the state itself. And what we can do, then we can jump into our storages project. And in this one, you will see a file called remote state TF. And this one says that, hey, there is something in other project. In this case, you will specify the path to the state file in a way, which corresponds to the path here, core VNets. So core VNets, this is like just templated version of it, saying there is another project that I will call VNets that outputs something, and I want to read what it does, what is outputting. And then how you are using it, that you could use a local, and then you say internal subnets. You are interested in specifically in the subnets that are created while you create the virtual network. And then you want to create, for example, storage account and make a network isolation for it, saying that the only place from where the storage can be accessed is the subnet created in this virtual network. That will be used somewhere else. For example, this integration data factory subnet, and it will be like created in completely different project, but then like we are actually like saying for this storage is okay to be accessible. And if you will be just running it, it will be able, just 1 minute and I'm finishing. So this storage pipeline, if you run the plan, it will kind of go through, it will figure out what's like it needs to be doing and so on. And then, it will apply it, and then we can maybe take a look into environment just as a final step to see how does it look like. It's in a different subscription. I think it's called management. So here is the example. Sorry, I wasn't able. So this is the this is the pipeline self-hosted agent setup, and where the state files will be saved for all of your environments and so on, all of your Terraform projects. And this is demo VNet virtual network that we created. And then this is the storage account, and in the storage account, it will go into the virtual network networking part. You can see that here is the subnet that has been added as to allow network traffic to the storage account. Yeah, so sorry, out of time, but there should be some references to it in the GitHub. So let me just fast switch into this one. And yeah, this is the process also describing. And here are like resources references to those GitHub repositories if you'd like to try it out yourself. And don't know if we have time for any questions. If no, yes?
To be able to load the state file in the script package, we need to create some additional resources, for example, the DynamoDB and link to state file path. I'm just curious to know, is there an Azure way to do that in Azure? Or
yes, yes. With the remote state that you are using, remote backend that you will use for Azure, if you use a storage account, that log happens actually automatically. Terraform, there is a way to log, it's a kind of naturally comes with the storage itself, and the Terraform is able to utilize that internal process of storage like file locking mechanism. So it will do it for you, that there will be no any like parallel execution of pipelines. But if Terraform fails for any reason, times out or any failure goes, your file will actually stay locked. So you will need to have some process of going and releasing the lock that it will become available again. Because no. Just like if any problem comes with a pipeline and it will stay locked, then you just need some way to unlock it. And there is like ways, for example, to do and automate that one as well. Any other? So yeah, if no, then thank you very much.